So in this video, I'll teach you how to graph sine and cosine, as well as others. We'll see how far we get. Probably at least get to tangent. So this, if you remember from 141, we had some parent functions. So really what we're doing here is adding some new parent functions to that list. And so we're kind of thinking of sine in different ways. So far we've been thinking of sine as the y-coordinate on the unit circle, where the terminal side of the angle passes through the circle. But now we're going to change that. So of course we'll still use that to find the values of sine. But now we're thinking of the input is the x-coordinate, just like normal, and the output is the y-coordinate, just like normal. So I'm going to plug in, and notice I have my x-axis keyed in with radian type measurements. I mean, it's easier to tell. Of course, this still goes. You can see there's like a 1, 2, 3, 4. Those are all still there. So it's scaled. The x and y axis are scaled the same way, and that's why we're using radian measures, so we can scale them the same way. So notice that I put pi over 2 at a little bit past 1.5, because pi over 2 is 3.14 divided by 2, which is about 1.6-ish. So notice I went, there's 1, there's 1.5, there's a little bit more than 1.5. So, and of course this up here is just 1 and 2, and -1, I mean. So we're going to try to generate some values, and we're going to do that by making a little x, y chart. And so, since we're plugging in numbers, it makes sense to plug in numbers that we know that are easy to find. And I'm thinking about with the unit circle, the easiest ones to find are on the xy axis. So I know this one, this one, this one, and this one really well. So we can run through those really quick. So when I plug 0 into sine, okay, sine of 0 is 0. That's this guy right here. The y value is 0. So that means it's right there. Now let me change my color so you can see it when I start graphing. Okay, when I plug in pi over 2, whoops, a daisy. When I plug in pi over 2, that's the next axis. Well, then my sine value is 1. So when I got to pi over 2, I hopped up to 1. So I went from 0 to 1. The next one would be pi. That's the next axis. So if I turn pi radians, I'll be on the negative x-axis. And of course, sine of pi is 0 again. So I come back to 0. The next one would be down here. That's 3 pi over 2. And at that point, the y-coordinate is -1, so that'd be -1 there. And so I come down here and put a little dot. And then finally, I come full circle to 2 pi, back up to 0. And then, if we understand this correctly, it starts repeating itself, doesn't it? Because if I go to 5 pi over 2, that's the next thing out there, that's back to the same place I was before, so that's back up here. Notice that this is the same as that, as far as their coterminal angles, which means they produce the same sine value. And then this one would be the same as that. So that's 1, etc. And we just keep cycling. So now, what does it do in between? Well, it doesn't take much to think about that the y values are coming from this curve right here, which tells me it's got to be curvy. And you could plug in some points to make this clear to you, because you could do sine of pi over 3, sine of pi over 6, sine of pi over 4, and sine of pi over 3 pretty easily off the top of your head. And what you'll find out is that there's a bowed curve like this. And it also curves down like this, and then like that, and back up. And so it just goes from 0 to 1 to negative, or to 0 to -1 to 0 to 1, etc. It keeps flowing. And if we go the other way, notice if I put in negative pi over 2, that would be going back here. That also produces a -1. So that would be right down there. And so you can see that it just flows like waves. And it begins to repeat itself right there. Or, I'm sorry, right there. So you can see, if we were to highlight this, can I grab some yellow? Let's see, a yellow highlighter. So this part right here, that's one cycle of sine. So notice once you get past the yellow, it just starts repeating itself. It does the same thing it did before. So that's the graph of sine, y equals sine x. This is really important for you to understand. You want to, of course, if you understood this process, you can easily regenerate it. I wouldn't recommend you memorize this. It's pretty easy to know that all you have to do is plug in that first value and get 0, and then you know it goes up, down, and keeps flowing. So it's pretty easy to get in your head, but some people will take more time than others. So whoever you are, you want to take the time to make sure you know this graph well. Notice it's hitting a x-intercept every pi, so there's 0, pi, 2 pi, 3 pi, 4 pi, 5 pi. Notice it hits a max at pi over 2 and a min at 3 pi over 2, and then another max at 5 pi over 2. So every other odd multiple of pi over 2 is a max, and every other multiple of odd pi over every other odd multiple of pi over 2 is a minimum. So there's some things you can observe about that, but the key, I think, is really important to notice that the domain of this thing is all real numbers. There isn't any breaks in the graph, and the range, this is really important, goes from -1. Oops, that should be a y. We're talking about range. From -1 to 1. It never gets higher than 1, never gets below -1. Okay, so if we move along, if we do the same thing with cosine, I'm going to just draw the circle here and not even plot the points in the little XYT chart, or the XY chart. It's called a T chart because it looks like a T. So we'll do a little pi over 2 there, and that'd be 6 plus a little bit, pi over 2, and 9 plus a little bit more, and 12 plus a whole lot more. That would be pi over 2, pi, 3 pi over 2, and 2 pi. There's 1, there's -1. Okay, so think about 0. When I plug in 0, cosine of 0 is 1. We're talking about right there, cosine is 1. So let me change my color again. So we start out right there this time. Notice in the sine we started at 0, here we're starting at 1. Okay, when I go to pi over 2, that would be right there. My cosine value is 0, so I'm back down to the beginning, the x-axis. When I go to here, cosine is -1, so now at pi I'm at -1. When I come around to here, cosine is 0 again, so I'm back up 0 at 3 pi over 2. And I come back full circle. Cosine of 2 pi is the same thing as cosine of 0, which is 1. And it is also curvy, so it's going to flow like sine does, up and down, has the same domain, same range. It looks actually really similar. The only difference is it's shifted to the left a little bit, isn't it? If you were to shift this to the right, it would look just like that, wouldn't it? Or if you shift sine to the left. And once again, you see that it repeats itself out here, so it would go down to 0 again and hit -1 and back up, etc. This is going to come down and hit 0 at -pi over 2. So I think it'd be very helpful for you to maybe shut off the video and try graphing this on your own, and then turn it back on and re-watch the video. But you want to get good at producing these graphs. So I would say pause the video right now and work on that, because where I'm going to go next is we're going to graph y equals tangent of x, which we all know is the same thing as y equals sine of x over cosine x, and that's exactly how I'm going to graph it. So if you're feeling good about the two graphs above, you can keep watching the video. If not, I would pause the video, practice them, make sure you understand them, or maybe go back and rewatch the video, make sure you understand the sine and cosine, because that'll help you understand what I'm about to do next, and that's tangent. Okay, so here we go. Tangent x. So like I said, I'm going to think of tangent as sine over cosine, because that's what it is, and I know sine and cosine really, 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 really well. So I'm going to graph just like I did before. Whoops, I put -1 there. That's embarrassing. Put a 1 and a -1. Put a pi over 2. Probably put a little negative pi over 2 out here. Put a pi right there. Put a 3 pi over 2 and put a 2 pi. Okay, so let's start thinking about this. So when sine is 0, okay, so here's my unit circle. It might be helpful to see these values or just think about the sine curves. Well, anytime sine is 0, notice that the overall fraction is going to be 0 because 0 over anything else other than 0 is 0. So if I scroll back up to the sine curve, sine is 0 at 0, pi, 2 pi, etc. So that means the tangent is going to be 0. Let me change my color again. Let's go with green. So when sine is 0, tangent 0. So tangent would be 0 at 0, pi, 2 pi, and if I went the other way, it'd be negative pi. Okay? Notice also, when cosine is 0, then we'd have something over 0, and we all know that you can't divide by 0. So whenever cosine 0, tangent's going to be undefined. So that means, and we know the cosine, if we scroll back up real quick, cosine 0 at the pi over 2's, like negative pi over 2, 3 pi over 2, etc. So cosine is going to be 0 at negative pi over 2, and 3 pi over 2, which means tangent will be undefined. What happens when we get undefined? We have a vertical asymptote. So I have a vertical asymptote at pi over 2, negative pi over 2, 3 pi over 2, all the odd multiples of pi over 2. Okay, so this is beginning to look interesting. So we have a 0 here and a asymptote there. So now what's happening in between? So let's go back to this middle one. When at the very beginning, if you can picture sine is going up, right? And cosine is coming down. Okay? So as we go through here, so as we leave 0, sine is getting bigger and bigger and bigger. Cosine is getting smaller and smaller and smaller. So if you look at the fraction, if this is getting bigger and this is getting smaller, that means the overall fraction is getting larger because I'm dividing a smaller and smaller number into a bigger and bigger number. So again, sine is getting closer and closer to 1, and cosine is getting closer and closer to 0. So you think like 1 over 0.01, or 1 over 0.0001, or 1 over 0.0000000001. If you throw that in your calculator, you'll see that these are really large numbers. So as sine gets closer, and of course I understand that sine's not 1 here, but it's really close to 1. Okay, so as sine gets closer and closer to 1, cosine is getting closer and closer to 0, which means the overall fraction is getting big. Big. Oops. Okay, so that's, we're talking about this little quadrant right here between 0 and pi over 2. So and as sine gets bigger and bigger and bigger, cosine gets smaller and smaller and smaller. That means tangent is also getting bigger and bigger and bigger, but it's getting huge because notice like 1 divided by that is a really large number. So what happens is tangent ends up in a curvy way, but it takes off because we know when you get close to a vertical asymptote, it either has to go straight down or straight up. So this thing is getting large without bound. Humongous. And notice that both sine and cosine are positive in this area too, so we know that it has to stay positive. So it's getting bigger and bigger and bigger. Now, when we get to the second section, so we're going from, think about from pi over 2 to pi, right? So we know that sine is coming down like this, and cosine is going down like that. Oh, interesting. And sine is getting close and close to 0, so that we're getting right there, right? But notice, first of all, that sine is positive and cosine is negative, which means when you divide a positive by negative, it's going to be negative. So that means we're going to be down in this area, this realm for that quadrant. And since we know it's headed towards 0, it's going to have a similar effect as the last thing, only we're going to be coming from down there. So this is getting, as y gets, or as sine gets closer and closer to 1, cosine is getting closer and closer to 0. So it's the same effect here as on the other side, except for cosine's negative and sine's positive. So we have the same effect here, but it's a negative effect. So it's doing this thing. And that, of course, again, makes sense because we know on either side of an vertical asymptote, the only behavior a graph can have is to shoot up into space, up into large positive numbers, or shoot down into large negative numbers. Okay, and if we keep going, when you get to the third quadrant, so that would be from pi to 3 pi over 2, notice cosine is still negative, but sine is also negative, so they're both negative now. So now we're dealing with a positive tangent. So it's going to do the similar behavior it did before, but it's going to take off like this. And it seems like we're already repeating myself because this guy and this guy are the same. So we could go back here real quick and investigate. And sure enough, if we look at from 0 to negative pi over 2, on cosine is positive, sine is negative. So it makes sense that tangent would be negative there. So this is going to do a similar thing as it did before. So notice that in sine and cosine, it takes a full, you go from 0 to 2 pi before you start to repeat yourself. That's true in both of these. But in tangent, notice you go from negative pi over 2 to pi over 2, and then it repeats itself after that. So we would call that the period. The period of sine is 2 pi. The period of cosine is 2 pi, but the period of tangent is pi. So it just takes less time before it repeats itself. So tangent is repeating itself every pi, a distance of pi on the x-axis, whereas sine and cosine it's every 2 pi. Okay, so I think I'll stop the video there. That's got 3 of them. The other 3 are reciprocal functions, so I'll make another video talking about the graph of the other 3.